Hello, this is Miss Alexander at Mercer Middle School. I'm going to make this video on how to make a toolkit. I'll target this toward the Interim 2 for 8th grade in 2017-18 with Miss Allen, Miss Agapov, Mr. BR, and Mr. Dixon. So as I'm making this toolkit, I'm looking at the team review or practice interim. It is 8 pages long. It covers approximately 8 standards, and I'll be going through just page by page talking about what to look for on the interim for figuring out what goes on your toolkit. So a toolkit in general is a document that you can use during your test. It is the only document you can use during your interim. It's kind of like a cheat sheet. And the process of making the toolkit, though, is part of the studying process. You're going back over your notes, you're going over your practice test, you are figuring out what the important information is. So again, that is part of the studying process. So, while we're not going to stop you from copying someone else's toolkit after they've made it, realize that that is not the most useful way of using a toolkit. Really, it's going through your notes and figuring out what goes in a toolkit that helps you remember things when you're actually taking your test. It is nice to have certain things on your toolkit to look at during your interim. For example, certain like slope formula or the structure of a linear equation. But going through and finding that information really is the helpful part. So I'm looking at page 1 of the team review. The standard is understanding solutions to a system of 2 linear equations. And I'm seeing question 1 says create a system of 2 linear equations that has a solution and graph the system. So there are 2 pages to this interim, and it's full page for an interim. So I've got this toolkit has 1, 2, 3, 4 down there, and then another 4 boxes in the back. It's a total of 8 boxes, and there are 8 standards. So or 8 pages of the interim. So I'm just going to focus on this first box here. So first of all, I don't need to write the standard code here, but I can write page 1 if I want to. I'm looking at what is a solution to a system. It says graph the system here. So I'm going to put an x-axis here. I'll put a y-axis here. And I want to show a system. So I'm going to draw 2 lines. So I've got, let's say I want the system solution to be at 1, 1. I need to make sure that both of the lines have a solution at 1, 1. So that line has some slope. I don't even care what the slope is right now. All I care is that it has a solution here. And then I'll put a line right here. So I'm going to mark on my toolkit that, that this is a solution. And I'm going to say what the solution is. It's 1, 1. And I'll even put solution at 1, 1. And so this is a system because it has 2 lines. I'll say line A and line B. And that's it. I mean, that's just for me. I'm not going to write too much here. It's just a little reminder of what it is that question's talking about. That 2 lines cross at that point. Question 1b on the team review is talking about a system of 3 linear equations, and it gives me 3 word problems. So I tried to think of the best way to make this video and whether or not I should actually show on the screen what the team review looks like, but I think it's more helpful. It's going to be kind of crowded if I do that. It's going to take a long time. So I'm just going to talk through what I'm seeing on the page and assume that you have a team review in front of you. Also, remember there are other videos on this YouTube account. You can look for Math8, Interim 2, Practice Test, page 1. That video goes through this exact same page I'm looking at right now. So I have 3 different companies, and each company needs an equation. So I should probably remind myself on this toolkit how to write an equation. So if I want to write an equation, if it's proportional, it's y equals kx from 7th grade, but most of our equations in 8th grade are in this form. Y equals mx plus b. So for example, it says company B charges $5 per hour of work. So I'm going to label on here that the M would be the rate or the unit rate. And so I'm going to say $5 per hour. So $5 per 1 hour. And that the B value, it says plus B. In this story, it says a one-time fee of $20. So I'm going to say this is the starting cost. I'll just write start, and it would be $20. $20 one-time fee. So these are some examples of things that I would write if I were you to mark up my toolkit to remind myself. Remember, you're not writing every single thing down. There's not going to fit, and it's going to be confusing and overwhelming when you look at your toolkit during your test. You just want a couple little things that are going to remind you. And then it says, which company should Alexander choose? So you're going to end up with 3 different graphs, and I'm not going to try to fit that all in here. Some people, when they're making a toolkit, they end up trying to copy every single thing from their interim practice onto the toolkit, and that's just too much information. So if I think about this, there's really nothing else to write. I do want to have maybe a graph because I do end up having to graph these. My copy on here does not really show the lines very well, but on yours the lines show up a little bit better, and this is what your graph looks like. You have a y-axis, you have an x-axis, and then I'm just going to do a quick reminder for myself that the y-axis, the starting value, so let's say for example $20, 5, 10, 15, 20, let's pretend it's 10 actually, 10, 20, just so it'll fit on my graph. Remember, you can change your scale as long as you're consistent by what you're counting by. So I'm going to put 0, 20, I'm going to mark that as my B value. And then I'm going to put my rate at, let's say this is counting by 5s, or 10s here, and these are counting by 1s. So there's 1, 2, 3, 4, 5. Remember, I'm estimating here. This is not exact. And this I counted was 10, 20, so halfway would be 5 and over 1. 5 again over 1, and that should be enough. I have 3 points now, so I'm going to draw a line through my 3 points. And then to remind myself where I got that line from, I'm going to put a slope triangle right here. That is $5 for 1 hour. The change in y was 5, and the change in x, it was 1. $5 for 1 hour. So I think that's a good summary of what's happening on that first page. So I'm going to look at page 2. Page 2, find the solutions to the systems of linear equations. You could copy these exact systems onto your paper. I wouldn't recommend all 3 of them. There's 3 systems on this page and only 1 little box. So I'm going to look at the ones, now this would be different for you. I'm going to look at this page and think about which ones I personally might make a mistake on. So if I was an 8th grader, I'm looking at 2a, and it says x equals, I'm going to erase this in a second, but I'll just tell you. The first one equation says x equals 5, and the other equation says y equals 1/5 x minus 10. I'm going to look at that system and think, what would I do to solve that? Is that easy for me to do, or is that difficult? If this one feels easy for me, like I'll think about x equals 5, and so I'm just going to go in here where x is 5, and I'm going to put y equals 1/5 times 5 minus 10, and I can now solve for what y is and then find out what x is. I mean, that feels fairly easy for me. I don't think personally if I was an 8th grader I would need that one. If you feel like you need that one, fine. You can write that down, but remember there are 2 others. You won't be able to fit all 3 here. So I personally am not going to need this. So I am going to erase it and focus on copying down a different one of the 3 systems that I will need. So I'm going to look at number 2. Number 2 looks like this, y equals 4x plus 2, and the other equation says y equals negative x minus 3. That system also to me seems a little straightforward. Maybe I don't need it. 4x plus 2 equals negative x minus 3. Y equals, and y equals this as well, so they must equal each other. Think it through, add x on both sides, subtract 2 on both sides. That also to me feels fairly straightforward, so personally I wouldn't need that one. Again, if you feel like you do, go ahead and copy that one down. The third one's a little more complicated, so I'm going to choose that. I'm going to choose the hardest of the 3 personally to write down. So this one says the first equation is x equals, oh sorry, my mistake, x equals. And be really careful. If you end up making a mistake on your toolkit and then you are using that on your interim, you might confuse yourself. So have maybe someone else check over your toolkit when you're done with it. There's no mistakes on there, or just double check what it is you're copying from. If you're looking in your math notebook and you have an example that your teacher gave you, just make sure that example is correct. So I've got one equation and another equation. And it's not obvious here what's going to happen. These both don't say y equals. One of them is not a simple equation that just says x equals a number or y equals a number. That's why I chose this one. Also, be careful about how big you're writing. I wrote a little big on this one, so I'm not sure if I'll have enough room. So I'm going to write a little bit smaller as I work here. So it says y equals this expression. So I'm going to find y in the other expression, or the other equation, and substitute. X minus 2 blank equals 6. It says y equals negative 2x plus 2. So if I were to substitute, then I would be able to find where they equal each other or where they share a point on a graph. So I'm going to draw a line here, and I'm going to go x plus 4x. Negative 2 times negative 2 is positive 4. Negative 2 times positive 2 is negative 4. Equals 6. X plus 4x is 5x. Add 4 on both sides. Just for the sake of time, I'm not going to show my work on that, but I'm adding 4 on both sides. Again, for the sake of time, I'm not going to show my work. X equals 2. Remember, I'm not done. That is something important for your toolkit, is reminding yourself, maybe even write yourself a note. I am not done, period. Find y. That's a little note that you'll remember that you need to come up here, and I'll switch colors. You have your solution. I'm going to write solution right here. Now I'm changing colors a lot. I'm using color to have you see the difference between different parts of these problems. I do recommend the use of color on your toolkit if you're using it for not just making something pretty, but for example, notice I changed colors when I did my substitution. I changed colors again to give myself a little note, and I'm changing colors one more time so you can keep track of how I'm finding my solution. X is 2, comma. I'm doing this in purple so that over here when I do something in purple you see these are connected. Again, you can use color in your toolkit, but don't just try to make it pretty. That's not as useful. X is 2, so I'm going to find either one of these equations and put in what X is 2 and find what Y is. So I'll take the second one, Y equals, it doesn't matter which one you pick. We go over that in the video. On the other video that goes over page 2, that's posted on the same page. Negative 4 plus 2. Negative 4 plus 2 is negative 2. So my solution is 2, negative 2. So this to me is a really nice summary of how to find a solution to a system. And again, I picked the hardest of the 3 on that page. So that's going to be useful to me. You can in your head check this. You can even write yourself a little note in red. Check other equation 2. So that little note tells you, well, I'll just make sure here. So x is 2, so look at the first equation. X is 2 minus 2y equals 6. Subtract 2 on both sides, divide by negative 2. Yep, it does actually work. So that's just a reminder to yourself that you can check as well. Notice there's still some extra space here. There's other things you could do up here, or you could have written a little bit bigger, but I think that's good enough. Going on to page 3. Remember, this does not have to be exactly what your toolkit looks like. This is just an example of how to make a toolkit. This is what I would write personally. Don't feel like you could just copy exactly what I'm doing here. I mean, everything I'm writing would be useful for an interim, but there might be things you might need on here, little notes to yourself that I'm not writing on here at the moment. You can also put words of encouragement to yourself. If you know this is a standard you get stressed out about, I've had students before just write little words of, for example, take a deep breath. Take a deep breath. Or you might write, just even like dorky little things like you can do it. Take your time. Decorate it with little pictures if that keeps you less stressed. Stress is useful to a point when you're taking a test. Stress can make you focus, it can make you take it seriously, but too much stress will turn your brain off. So if that helps you, I know a lot of students really feel like they get comfort from that. So go ahead and add those notes to your page. And just little doodles, little drawings, little cartoons that make you smile. If you have extra space on the outside, that could be a good idea. All right, so page 3, we have solve real-world and mathematical problems leading to two linear equations in 2 variables. So this is another systems standard. So you're going to have these different equations you'll have to write and look at in order to figure out if the system has a solution or not. So I'm not going to go over every part of this. I'm going to speed up a little bit here now that I've kind of walked you through how to do this. I'm going to look through this page, look through my notes, look in my notebook, whatever I can see that looks similar to this. A line has a slope, I'm reading question 3a. A line has a slope of negative 3 and goes through a point 34. Determine the equation of the line. We already did some of this work. There's some overlaps in these standards. The equation of a line, I don't need to rewrite this. I already have it. So if I'm looking for the general form of a linear equation, it's right here. So I'm going to skip writing that part. But something I will need in a second is how to find a b value if I have an m value. That's really what this question is getting to. So I'm going to go to 3a and see, let's say I have a slope, I need y-intercept. So let's say I have a slope, that is my m. I need a y-intercept, that is a b. Notice I'm marking this up in a sentence because I'm talking to myself, essentially, something I can read over during my interim time. So I'm going to walk through that process. Y equals mx plus b. I have a slope, it tells me y equals negative 3x plus b. And I also, let me write here, I have a point. That's going to be useful. So I'm going to write my point, 3, negative 4. Now again, notice I'm switching colors when it's useful to mark this as an x value and this is a y value. So I'm going to use that right here, using arrows to remind myself what's happening. So y is negative 4. So I'm going to put a blank here. Negative 3, and then x is 3. I know this is a solution to my linear, or to this equation, therefore it would, by substituting it into my equation, it would eliminate all the variables except for b. So now if I know my x, it is 3, and I know my y, it is negative 4, the only unknown I have left is b. So now I can find out what b is. So I've got negative 4 equals negative 9 plus b. And again, you know, if you need to show the work in order to, if you are going to forget that you're adding 9 on both sides, I'd recommend showing that work, plus 9 plus 9. If that's not an area that you struggle with, if that's something you can just do in your head and know that you're not going to make a mistake on your interim, then don't write the plus 9 on both sides. This is for you. So whatever you need, really. If you need to cross this off and write 0 plus b to remind yourself that you're making 0, then write that down. If you don't need it, then don't write that down. 5 is b. So then I'm going to write here, it says determine the equation of the line, so I'm going to write equation of line is y equals, slope was negative 3, and I found my y-intercept, it is 5. So there's my answer. I'm going to put a box around it because that was the whole point of the question. So one problem with this is that notice I've taken up an entire section. Remember, I only have 8 pages and 8 boxes. That's only question 3a. So now I still have 3b and 3c, but I wrote all this because I know personally as an 8th grader maybe I've been struggling with that question. I noticed on my team review during class last week that I didn't know how to do that. I'm nervous I'm going to forget how to do it. So that would be something I would want to write down. But if I look at 3b, it says determine the equation of a line with 2 points given. Well, I already know how to find an equation of a line if I have a slope and I have a y-intercept. Those are my notes right here. The only part of 3b that's new is that they gave me 2 points and they didn't give me the slope. So I'm still going to find the y-intercept b given the slope. The only thing I need to do right now is find the slope in part 3b. So I'm just going to write my slope formula. Slope. You don't have to stay in the box, by the way. The boxes are given just as a way to organize, but you can go out, it's your paper, you can go outside the box. So determine the slope. Slope formula is y2, take away y1, over x2, take away x1. And then if you need a reminder, you can also put that, oh, you already have it here, the x and the y from 2 points. So really, I don't think anything more than this needs to be written as long as you know what to do. Once you have your x1 goes here, your y1 goes here, and then you have your second point, that would be x2 and y2 from the page. So that's really all you need. And then it says, will the system of linear equations created by 2 lines described above intersect? If yes, what is the solution? Well, once you have 2 equations, you have notes up here on what to do to find a solution to a system. So, as you see, as I go through all of these, I'm writing down what's essential, what is necessary, what I need to remember, what I'm worried I might forget. I'm not writing everything. If I look at page 4, I see it's on scientific notation, so I'm just going to put a couple little notes on scientific notation. So I'm going to write, you can also use these as headers, scientific notation. Some notes that I also anchor charts. In your classroom, in your math class, you have posters on the wall that summarize some of the big ideas. Your teachers work hard to make sure that they're not too crowded. There's not too much information on those anchor charts. So that means that what's located there is the important, essential information you're going to need. I know that all of your 8th grade math teachers have a poster that has this on it. D times 10 to the n. That's important because that's the form of scientific notation, a number written in scientific notation. And they also point on here and say that D has to be less than 10 but greater than 1. That's important. Also, there's something pointing here saying if n is negative, this is a small number, and I'm going to use a pound sign to show number so I don't waste room. And if n is positive, it makes a big number. It's a good summary of something in scientific notation. That actually covers, if you're looking at your interim right now, or your practice interim, 4A and 4B are pretty much covered there. How to write something in scientific notation, and then you can make a note to yourself. It says write it in standard notation. Standard notation just means a number written out using a place value system. So like 2, 3, 0, 0, 0, 0, 0. You'd change that into scientific notation by saying 2.3 or 2 3/10, and then counting 1, 2, 3, 4, 5, 6 times 10 to the 6th. So then we have 1, 2, 3, 4, 5 zeros, and then one more place value movement, so 10 to the 6th. So then this is scientific. So really, you don't need 4 examples for that. You just give yourself one example. And then it has a number that is written not in scientific notation, so maybe you want an example of that. So if you say like 63.4, 0, whatever you want. Actually, let's put a 2 right there. That is not in scientific notation, so let's put an arrow and say fix. You know this D value. This is too big, so I need to make it 6.3402 times 10 to the, this isn't even scientific notation in the first place, let's fix that, times 10 to the 4th, let's say. So it was 10 to the 4th, but I made the number 10 times smaller, so I have to make the place value 10 times bigger. So 10 to the 5th. And then check your work. These need to be equivalent. So if this is 5 place values to the right, or 10 times bigger to the power of 5, so that'd be 1, 2, 3, 4, 5, there'd be an extra 0 here. And this says 4, so 1, 2, 3, 4, there'd be an extra 0 there. Those are equivalent. So that's about all you need for scientific notation. There's a tiny little standard here, 7RP2C on page 4, that has to do with a proportional relationship. I'm going to skip that for now. Y equals kx. I'm not going to take up one of my boxes for that. But proportional relationships you can review on your own. The next page is operations with scientific notation, or essentially looking at exponents. So that is one where you might want to write down some properties. So depending on how much you struggle with scientific notation exponents, there might be a lot of properties you might want to write down. But if I look at the next page, that has more exponent properties. So you might actually be able to spread out your exponent properties between both these boxes. So let me see how much time I've done. We're at a lot at 24 minutes. I'm actually going to stop there. I'm going to let you finish your toolkit. I hope you get the idea by now what to do. You're really going through page by page, finding areas you're struggling with, finding areas that you might be getting nervous, and writing things down. I went through half of this. You still have a whole nother page that you could fill out here. If I continued, this whole video would take an hour. But notice that it does take time to make this. This is not something you make for 10 minutes scribbling something down just to get it done. This is your way of studying. This is how you're structuring your study time so that you know when you're spending that time looking through your notes, you're finding things that are important for you. So your toolkit is coming from your notebook notes, it's coming from anchor charts in your teacher's classroom, it's coming from looking at your practice interim. If this was a toolkit for a quiz, it would only be a half sheet of paper. You'd get a total of 4 boxes, not 8 boxes, but it'd be a very similar process. You'd go through your do now problems that were similar. You'd go through the anchor charts in the classroom or your notebook or classroom assignments that you did. You can also come to morning math and get help with the toolkit there, or go to your teacher at lunch. Go ask your friends to look at their toolkit, see what they're writing down. It is something that should take time and should not be just done at the last second. So I hope that was helpful, and good luck in your interim tomorrow.